Hi, this week we're going to talk about polynomial functions. We're going to talk about their end behavior and some characteristics of them. Let's go ahead and get started. So here's the official formal definition of a polynomial function, and it looks sort of worse than polynomial functions really are. In fact, they're actually quite easy to work with. Polynomial functions are of the form f of t equals a sub n t to the n plus a sub n minus 1 t to the n minus 1 plus all this other stuff. Where the AIs are any real numbers other than zeros and n are positive integers. So let's look at an example of a polynomial function and some non-examples to get a little bit better feel. This definition isn't super helpful sometimes. So polynomial functions are functions made up of power functions. So x to powers, and the powers need to be non-negative integers like 4 or 3 or 2 or even 0 because we have a constant term. Polynomials cannot have fractional powers like x to the 1/2, so root x would not be a polynomial. They can't have negative powers, so this h of t is not a polynomial. And again, they also can't have fractional powers, so again, no 3/5. So they're just basically going to look like a number times x to a nice non-negative integer power. All right, so if we look at the general form of a polynomial, that a sub n t to the n is called the leading coefficient, or leading term. And a sub n is the leading coefficient. And n is the degree. So those are all terms that words you're going to need to know about polynomials. And the end behavior of a polynomial is going to be completely based on that leading term. So let's look at a couple of really great polynomials. The first one I want to look at is x squared, and the next one I will look at is negative x squared. So polynomials with an even degree, so any even degree polynomial, 2, 4, 6, 8, whatever, all of them are going to, in behavior, act like either x squared or minus x squared, depending on if their leading coefficient is positive or negative. So what that means is they're going to go up to the left. As we look to the left here, this is going up. So up to the left and up to the right. Up to the right. If they have a positive leading coefficient, and if they have a negative leading coefficient, they're going to go down to the left and down to the right. So even polynomials always act like x squared, and their end behavior matches. So it's either going to go up to the left and right or down to the left and right. Odd polynomials either act like x cubed or minus x cubed. So x cubed goes down to the left here it is going down, but it goes up to the right. So their end behavior doesn't match. Odd degree polynomials end behavior doesn't match. Even degree polynomials end behavior does match. If the leading coefficient is positive, it's going to look like this x cubed. If the leading coefficient is negative, it's going to look like minus x cubed, which goes up to the left. So as we're looking left, it goes up, and as we're looking right, it goes down. And those are really pretty much your options for what polynomials can do. So let's go ahead and look at an example of this. So here is our first polynomial that we're going to look at. It's 32x to the 6th minus 2x to the 5th plus 8x minus 3. The leading term is going to be 32x to the 6th because it has the highest degree. So our leading term is 32x to the 6th. The leading coefficient is 32, and the degree is 6. So what is the end behavior of this polynomial? Well, the leading coefficient is positive. The degree is even. So its end behavior is going to match x squared. X squared is our smiley face, so its end behavior is up to the left, up to the right. Okay, let's do another example. All right, this polynomial is r of x is negative 5x to the 4th minus 2x to the 7th plus x minus 4. What is the leading term? Well, it's tempting to say minus 5x to the 4th, but this is actually a trick. Sometimes polynomials are not written in order of decreasing degree. So by decreasing degree, the highest degree is 7, then 4, then 1, and then the constant term. So we need to rewrite this in order of decreasing degree to make this a little easier. So I'm going to rewrite this, and then 2 is actually negative. So negative 2x to the 7th minus 5x to the 4th plus x minus 4. So you got to watch out and make sure your polynomial is written in order of decreasing degree. Once it is, this becomes easier. So the leading term is negative 2x to the 7th. The leading coefficient is negative 2. The degree of the polynomial is 7. And what is the end behavior of this polynomial? Well, the leading coefficient is negative. The degree is odd, so it's going to act like minus x cubed. And if we don't remember what that looks like, it looks like this, more or less, minus x cubed. So it's up to the left, down to the right. If you don't know off the top of your head what x cubed, minus x cubed, x squared, minus x squared looks like, I would absolutely put those quick graphs on your note card. Just make a little chart and draw those in.